In this video, we're going to discuss something called polar coordinates, which is a different way of graphing from what we're used to. What we're used to is using a Cartesian coordinate with x and y, and so we're going to talk about how to graph with polar coordinates. And our goals for this lesson are to graph points using polar coordinates and converting from polar coordinates to rectangular coordinates or from rectangular coordinates to polar coordinates. Make sure that you write down the goals as your essential question in your notes, and be sure to set up your paper in Cornell format. Okay, so at the beginning, let's just talk about the difference between rectangular and polar coordinates. Rectangular or Cartesian coordinates are what we're used to. And in rectangular form, we're given an x value and a y value, and the x moves horizontally and the y moves vertically. So we're kind of moving in a rectangular direction because we're moving just horizontally and vertically. In polar coordinates, you're talking about revolving around a pole. The pole would be at the center here. It's like the origin. Okay, so I am using r and theta for coordinates. The r represents the radius or the distance away from the pole that I move, and the theta is the angle that I rotate. Okay, so the r, again, the radius or the distance away from the pole that we would move, and the theta is how far I'm going to rotate. So let's just look at some points in polar coordinates and let's see how we can graph those on a coordinate. Now again, the polar graph looks a little different than the rectangular. Okay, but there would be a rectangular point that corresponds with each one of these points. Okay, so let's start with point P. And remember, the first coordinate is your r, and the second is your theta. And I know when we graph in rectangular, we're used to moving x and then y. On polar, it's going to be easier if you'll find your angle first, and then use your radius. Okay, so notice that every angle in this graph has a spoke. Okay, so if my theta is 5 pi over 3, then I'm looking at this spoke right here of the graph. Okay, now where do I put my point? Well, I put my point a distance of 4 from the pole. So I need to count out 4 of these radius, 3, 4. So I want to go out a distance of 4. So the fourth concentric circle out at the angle of 5 pi over 3, and that is point P. Okay, try to graph point Q. So pause the video for a second, graph point Q, and then start again. Okay, so our theta this time is 7 pi over 6, and our r is 3. So the 7 pi over 6 spoke is in the third quadrant, and I'm going to go out a distance of 3. So here is point Q. Okay. Okay, now r, there's a little bit of a difference here because this time on point r, my radius is negative, and that's going to change one thing. But my theta is 5 pi over 4. So 5 pi over 4 is in the third quadrant. It's not actually marked on this one, but it's the spoke that's between 7 pi over 6 and 4 pi over 3. But if my radius is negative, then I want to count. I actually don't want to count out 2 this way. I don't want to put my point here. I need to go backwards. So I'm going to go to the spoke that goes the other direction, and I'm going to count the radius of 2. So this is actually where point R would be located. Okay, and there is another way to name that point. So we could call that, because this is the angle pi over 4. So point R could also be named with coordinates positive 2 and pi over 4. Okay, so if your radius is negative, count backwards. Count away from the spoke, the other direction. Okay. Okay, now in S we also have a negative, but this time it's the theta value that's negative. And recall back from when we started on trig, a negative angle meant you rotated clockwise instead of counterclockwise. So negative pi over 3 would be the same place as 5 pi over 3. And then my radius of 1, so point S would be in the fourth quadrant, okay, because we rotated negative pi over 3. So think about your negative angles. So that's how you graph a point in polar. You find your angle and then you count out that radius distance from the pole. Okay, now some things that we learned when we started in pre-cal with trig. Okay, let's take our triangle, our basic triangle, and our theta is our angle from the x-axis to our terminal side. Okay, so in this picture, our x distance is our horizontal distance. This is our x. Our vertical distance is represented by y, and we used r to represent the distance from the center to the point, from the origin to the point. And we had some formulas that we dealt with. For cosine, cosine was adjacent over hypotenuse, or x over r. Sine was y over r, and tangent was y over x. Okay? Now, when we're dealing with polar coordinates, we're going to want the x by itself and the y by itself. So if I take this same formula and I get the x by itself, I can write that as x is equal to r times the cosine of theta. Y is equal to r times the sine of theta. Okay, and then tangent equals y over x will be what we'll use to find our angles. And the x and y equations are going to, you don't have to learn anything new. These are equations we've had. We're just rearranging them. So those x and y equations we're going to use when we need to convert from polar to, or from polar to rectangular. Okay, now one other formula we're going to need, okay, is x squared plus y squared. And remember, in the triangle, x squared plus y squared would equal r squared because of Pythagorean theorem. So if we solve that for r, we will come out with r is the square root of x squared plus y squared. So these two formulas, the tangent equals y over x and r equals square root of x squared plus y squared, we will need when we're converting from rectangular to polar. So we're going to need these sets of formulas for different things, but both of them are for converting. So let's look at how we convert from rectangular or polar coordinates to rectangular coordinates. So rectangular coordinates means I want to know what does x equal and what does y equal. Okay, so our formula for x was r times the cosine of theta, and our formula for y is r times the sine of theta. Okay, now in our point, the first number in a polar coordinate pair is r, so r is 4. And theta is our 5 pi over 6. So to find x, I need to do 4 times the cosine of 5 pi over 6. Okay, remember 5 pi over 6 is in second quadrant. And in second quadrant, cosine is negative. And then we can use the hand trick to figure out what the value is. So pi over 6 would be your ring finger. And cosine would be square root of 3 over 2, because x over r. So we're going to do 4 times negative square root of 3 over 2, which is negative 2 times the square root of 3. Okay. For our y value, we're going to change from cosine to sine, but we're still going to use the 4 and the 5 pi over 6. Okay, so 4 times the sine of 5 pi over 6. Since we're in the second quadrant with the 5 pi over 6, the sign would be positive. And remember, sine is y over r, and my y would equal square root of 1, or 1, and then r is 2. So 4 times a half would be 2. So the polar coordinates 4, 5 pi over 6 would be negative 2 square root of 3, comma 2 in rectangular coordinates. So if I were going to graph that on the xy plane, it would end up in roughly the same place, well, in the same place as the polar coordinates on a polar grid. Notice both of these are in quadrant 2 because our angle here is quadrant 2, and this point is positive, negative, which puts us in quadrant 2. So that's something you can use to kind of check and make sure you're on the right track. But these are the two formulas that you're going to need when you're converting to rectangular coordinates. So be sure you highlight those formulas in your notes. Okay, now let's go the other direction. Let's change from rectangular to polar. So in rectangular coordinates, I've been given my x and my y, and I need to find r and theta. So let's start with the r. Remember the formula is r equals the square root of x squared plus y squared. So x is square root of 3, and when I square that, I'm going to get just a 3. Y is negative 1. Negative 1 squared is 1. So the square root of 3 plus 1 would be square root of 4, or 2. So my r value is 2. To find theta, I have to use the formula tangent theta equals y over x. Okay, so tangent theta equals negative 1 over square root of 3. Now the negative, don't worry too much about. What you need to look at is your point and see what quadrant you're in. So if I have a positive and a negative, then I am in quadrant 4. Okay, so I need an angle from quadrant 4. Okay, so again, use the hand trick to figure out what angle has a tangent of 1 over square root of 3. So I need my y to be 1 and my r to be square root, or my x to be square root of 3, which means I need the pi over 6 finger. Okay, but again, I need to I need to be in the fourth quadrant. So the angle in the fourth quadrant that has pi over 6 is going to be 11 pi over 6. So in polar coordinates, the point square root of 3, comma, negative 1 would be 2, 11 pi over 6. Okay. Now, I would like you to pause the video and try parts B and C and see how far you can get, and then turn it back on when you're ready or when you've gotten as far as you can get. Okay, so remember your formula for r is the square root of x squared plus y squared. So if my x is negative 3 squared is 9. Y is 3 squared is 9. So I'm looking at the square root of 18, which can simplify to 3 times the square root of 2. So r is 3 square roots of 2. Okay, for theta, we're going to have tangent of theta equals y over x, which is 3 over negative 3, or negative 1. Okay, again, the negative we're going to use to figure out quadrants. So if I have a positive, if I have a negative and a positive, then that puts me in quadrant 2. So I need my angle to be in quadrant 2. And how do I get tangent to equal 1? Remember, tangent is y over x. Well, to get tangent to be 1, that's got to be the pi over 4 finger, because your y and x have to be the same. So in quadrant 2, our pi over 4 angle is 3 pi over 4. So our polar coordinates for part B are 3 square root of 2, 3 pi over 4. Okay, on the last one, our r is square root of x squared plus y squared. Well, x is 0, so 0 squared is 0. Negative 2 squared is 4, so we're really looking at the square root of 4, which is 2, so r would be 2. Okay, tangent equals y over x, but this time when I put y over x, I get negative 2 over 0, which is undefined. So I can't use the hand, I've got to think about my unit circle. And there are 2 places on the unit circle where tangent is undefined, because I need my x to be 0. This is y over x. So to get x to be 0, that can either happen at pi over 2 or 3 pi over 2. Now how do I know which one to use? Well, look at the point that you were given, 0, negative 2. If I were graphing that in rectangular coordinates, I would go down 2 units. Okay, which if I'm going down, then that would be the angle of 3 pi over 2. So theta equals 3 pi over 2. If it had been positive 2, we would have used the pi over 2 because 0, 2 would have moved just up. Okay, so my coordinates for part C are 2 and 3 pi over 2. Okay. Be sure to highlight your formulas that you're going to need when you change from rectangular to polar, and then also the formulas you need when you go from polar to rectangular. If there was anything in the video you were unsure about, ask me the next time we have class.